This is video clip 4 of micro part 1, continuing with consumer choice, and in this video clip we focus on the budget constraint. So we're focusing on another thing we're all already experts on, limited income. Your preferences or tastes determine your wants, but your actual purchases are mostly influenced by your income and the prices of goods and services. Your budget is the amount of money you have to spend in a given period. We're going to look at this graphically, and we will draw a budget line to start with. A budget line or a budget constraint shows the bundles of goods that can be bought if the whole budget is spent on those goods at given prices. Another definition, the opportunity set, is all the bundles a consumer can buy, including all the bundles inside the budget constraint and on the budget constraint. Let's have a closer look. So let's continue with our example of Lisa spending her income on pizzas and burritos. We can write her budget constraint in this form. This simply tells us that Y, her income or her budget, is used up by what she spends on burritos, which is the price of burritos times the quantity of burritos, plus what she spends on pizza, the price of pizza times the quantity of pizza. That's her budget constraint, and it shows us that her expenditures on those two goods use up her whole budget. Let's rearrange that budget constraint to get it into a form that tells us how many burritos Lisa can buy. This is also going to be a form that's handy to graph when we draw the budget constraint just now. So rearranging to solve for B, her quantity of burritos, takes us to the bottom equation. So B equals budget over the price of burritos minus price of pizza over price of burritos times the amount of pizza. Simply rearranging to solve for B. So what does this tell us about how many burritos Lisa can afford? Well, just looking at the equation in general terms, we can see that she could buy more burritos if she had a higher income, or if the prices of burritos or pizza were lower, or if she bought fewer pizzas, because B depends on all those variables. Let's add some figures into this now. If the pizza price is $1, the burrito price is $2, and her budget is $50, then we can plug those into the equation. Her burrito consumption will equal 50 over 2 minus 1 over 2 times her pizza consumption, simplifying down to 25 minus a half Z, the pizza consumption. So on the basis of that, we can identify some bundles that Lisa could afford. Bundle A, 25 burritos and no pizza. That would use up her whole income because she'd be spending 25 times $2 equals $50, her whole income on burritos, not buying any pizza. Bundle D, spending all $50 on pizza at a price of $1 each and buying no burritos, also uses up her income. Bundles B and C also fit the bill. 20 burritos and 10 pizzas, or 10 burritos and 30 pizzas would also use up her whole budget. We can now graph her budget line. We're going to plot Lisa's budget constraint on figure 4.7. So from the previous slide and those figures we assumed, we already have our budget line equation in the green block. With burritos on the vertical and pizzas on the horizontal axis, we can then plot that budget line. Looking at the intercepts, on the burrito axis, we have bundle A. Remember that was where she only consumed burritos and no pizzas. That intercept tells us how many burritos she could buy if all her income were allocated to burritos and none to pizza. Similarly, on the pizza axis, if she spent all her income on pizzas and none on burritos, she'd be able to consume bundle D, or 50 pizzas. And we can also plot our bundles B, 20 burritos and 10 pizzas, and bundle C, 10 burritos and 30 pizzas, which also used up her full budget constraint or her full income. The shaded blue area shows her opportunity set, and the opportunity set, remember, is all the bundles that Lisa can afford. So it's anything that is less than or equal to her total income for those two goods. From Lisa's budget constraint equation, we can also identify the slope coefficient. which is the negative of the ratio of the prices of the two goods. Remember, the slope is the change in the vertical over the change in horizontal, change in burrito over change in pizza consumption. The slope of the budget line is called the marginal rate of transformation, or the MRT. Don't confuse that with the MRS, which is the slope of the indifference curve. The MRT also tells us the rate at which Lisa could swap burritos for pizzas in the market. It's the ratio of their market prices. So in the example we looked at, where the burrito price was $2 and the pizza price was $1, what that tells us is that a burrito costs twice what a pizza costs. So the ratio we had was 1/2 on that slope coefficient. You could give up one burrito and get two pizzas in exchange at market prices. Let's see what happens when the price of either good changes or if Lisa's income changes. First, let's focus on a price change. Let's say that the price of pizza doubles from our initial starting point. If the price of pizza doubles to $2, it's going to change the slope of the budget line. You can see this in a number of ways. Firstly, the slope coefficient on that equation is going to change because PZ is now 2. Also, if you think about what the intercept would be, if she now spends all her money on pizzas, she'll be able to afford only 25 pizzas, no longer 50, because the pizza price is now 2 instead of 1. In other words, the budget line will swivel inwards. It will swivel or pivot. The burritos intercept won't change because the price of burritos has not been affected. So if she spends all her income on burritos, she can still afford 25. However, if she spends all her money on pizzas, she can no longer afford 50, as she could at the old price. She can only afford 25 at the new, higher price. And we can also see as the line has swiveled inwards, it's become steeper. And that reflects the steeper slope. Her opportunity set has decreased by the pink shaded area. All of the bundles in the pink shaded area she can no longer afford. They are no longer part of her opportunity set. Finally, let's consider what happens to Lisa's budget constraint if her income changes. Let's suppose that her income doubles from $50 to $100. We will see that her budget line is going to shift to the right, parallel to itself, keeping the slope unchanged. So if her income rises to 100, her budget line will shift out to that new position. Let's look at the intercepts quickly. On the burritos axis, if she spends her whole income on burritos, the prices haven't changed, but her income has doubled. So 100 divided by the price of 2 means she can afford 50 burritos. If she spends her whole income on pizzas, she can afford 100 pizzas at the old price, unchanged price of $1 each. So the slope of the line has not changed because the prices haven't changed. However, its position has changed. It's shifted to the right, retaining the same slope. Her opportunity set has increased by the green shaded area, and that shows all the additional consumption bundles that she can now afford at her higher income level. In the next video clip, we're going to combine the consumer's preferences and budget constraint to look at the optimal choice.